I'm Justy14. I'm presenting you another project which is Java Embedded ML. What I'll do in this is first I'll emulate the legacy systems in Java, and second I would be creating a model in Python and exporting it as .ONNX format. So in Python file we input sklearn and some packages. We are using a simple iris.csv as you can see in the dataset here, and we are using label encoder to label the species, and basic train test split. We are using stratify to maintain proportions in both train as well as test dataset. Then we are creating a pipeline with scalar of standard scalar and using random forest classifier with 100 n estimators. Then we fit the pipeline and we predict it using normal things. We see the accuracy and the classification level and some of those things. The main thing is here we are converting the float input into a float tensor so that we can convert the normal float into a multi-dimensional array, which can be used in training or testing the model, as model takes tensor type float. Then I will be porting it out here on this directory, and I am writing the file. Now I'll run this file. I'm using a virtual environment so that it doesn't interfere with my normal Python in PC. It will take some time, and yes, so we can see there are 3 unique classes: the class distribution, data type, the label mapping, what is the accuracy, as well as it has a 90% accuracy, which is a proper, you can say. And yeah, so we have created the file. Now as per this, it should be in src main resources, so here we got model.onnx. so this is my code base for a legacy system. What I have done is I have emulated the Java 11, as you can see here in pom.xml. I have emulated 11, Java embedded available as artifact and version, basic things, and these are all my dependencies. Javelin, this is for logging, for JSON processing, and this is deep Java library which we will be using, and of course the main ONNX runtime engine. Then these are some plugins for transformers. So now there are 3 files: app.java, prediction service.java, and simple ONNX translator, ONNX translator. We are importing Javelin and some context for Javelin and basic hash maps. Then we are initializing the service, the basic things. We are creating a Javelin app. It starts on localhost 7070. Then I have defined 3 routes. One is predict, second is health, and third is test. For predict, this is the function. Now what am I doing is I am taking the body, the input from body. Now this is over HTTP requests, and I am separating it right here. So basically what I'll do is from postman I'll add this in the body, and then what I'll do is I'll send it. Now we are introducing float, new input. We are running the in-process method call as stated here. We are calculating the latency in milliseconds, hence why. To extract species name, we use this get species name, which is defined in prediction service.java. A simple hash map containing the response. This is the input from that, and there are other responses, which is predicted class, what species it is, and how much latency it took. It is sent in JSON, and it is also printed here. Now in handle health, it's just a health checkup, that if the state to check if the API is working or not. And in handle test, we provide some float tensor test samples and expected species, and we map that results using hash map, and we are using a flag all passed. We're basically predicting it species, and we are checking if all have passed. If yes, all test passed, otherwise some test failed. We are returning it in JSON. If any errors, we are printing it here. Now we will see the main prediction service. We are taking IO and NIO packages, as well as we are using DJL. Now in this prediction service, we are defining predictors and model, and we are defining species. Now we are loading the ONNX model in initialize. This will run first. We are converting it into an input stream, and then we are copying that stream to a temp file so that it can be worked upon. We are cleaning up any temp files, then we are closing the model, and now we will be defining the criteria here. The criteria would be the input class would be a float, and the output class would be a long. Then the model path as stored in temp file, the engine, and we are using simple ONNX translator, which I'll show you later on in some time. Then we are loading the model, and we are building the predictor, and then this is the predictor function, where it will check for any errors, illegal state or illegal argument, if model is not initialized, or the input does not have the exact number of features. And then we are using predict. Now it returns 0, 1 or 2, which is class labels as defined earlier in the video. Then we are getting the species name, basic checking that if it's 0, 1 or 2, and then we are returning the species. Then we are closing all the service, and service is closed. Now this is a basic translator code in which we are converting Java float arrays into a DJL and dimensional arrays. Now it handles data conversion for ONNX model inference, as ONNX engine uses its own n-dimensional arrays, and that's why we need to translate it from Java float arrays. This is a basic function. We are defining translator context. We are getting the manager, n-dimensional manager, and we are defining the n-dimensional array as taking from input to a new shape that is 1 by 4, in which we are converting the float to a n-dimensional array. And this is just a basic process output in which we are getting the list and we are outputting a long array. We are not defining any batchifier here. This is batchifier is basically used to convert unbatched n-dimensional arrays to a batched n-dimensional arrays for deep learning purposes. We are not using it in this simple project. Now I'll open the command prompt here, basic terminal. What I'll say is I'll first see mvn/version to check if it's installed. Yes, it's installed, version 3.9.11. Now what I'll do is I'll do mvn clean package. What this command does is that it will create a snapshot, a build of all of my Java files into a jar file. So including the resources here, the ONNX model, it will create a jar file, and you can see the jar file build is successful and it has took 20 seconds. Now the jar file, as you can see, it's here. What we'll do is we'll copy the name of this, and to run it now we will use java/jar and we will paste the jar file this. So now okay, so this was a mistake from my end. It's in target folder. So now it will run here. So now we have seen it on the browser. Now I'll open a Postman here. I've already defined the route here with post, and as per the code I'll have to write these features in the body. Now what I'll do is I'll click on send, and now we can see the input, the spaces it has predicted, the class and the latency. Now it says 1.13 second. It's rather big, but it's for the first iteration. The second time or the third time it varies. It's because there are multiple processes running concurrently. Yesterday when I tried, it gave me 0.8, 0.6. It does depend on your process. So now see, it also changes and the latency has been reduced. It was hallucinating. So yeah, this is the latency jumped to 3 seconds. So yeah, this is my project. This is all the predictions which are here. Javelin started in 0.5 milliseconds, and yeah, this is the original snapshot. This is the jar file, and the commands that you can run for these projects are the most important. First, mvn clean package, or you can write mvn package if you are doing it for the first time, but I would recommend mvn clean package. Afterwards, what I have to do is you have to use this command java-jar and the path for the jar file. It will open it. So yeah, this was my basic demonstration. And also there is one another thing. When I run this build, I have written a test file here. This is my test file. It's basically to predict while in jar file. So this is just a dummy input. We are using assertions, the predicted species. Now for this, the results would be, it has ran properly. As you can see the results above. Okay, input output prediction class, and it has predicted iris setosa, and then it has built it. So yeah, this was my project, and thank you. Any suggestions would be welcome in the comments. For more such projects, please refer my LinkedIn or YouTube as given on the screen. Thank you.